nm tells us about some of the function names, but it's not actually showing us the function. And of course, the function's source code is not in the executable anymore. The executable contains machine code, and we can look at that machine code translated back to assembly by using a program called otool. So O stands for object here, like as in compiled object. I'm going to pass it -t, which means to show me things from the text section, and I'll use -V, which means disassemble them and show me some names. And I'll give a.out there as the program. And what we see now is, well, it doesn't wrap up. I'm going to move over to this other window, do the same thing there. I'm going to use TV smashed together as one flag, a.out, and now we can see a little better that we have the function here say hello, and we have the function main, and these are the assembly language instructions that implement that function say hello. They're machine code instructions that have been disassembled to show us assembly language here. We also see that there are some instructions like this one that are getting a function or some sort of string, like in this case, and the disassembler is able to tell us that that corresponds to these names that are supplied either in this file or somewhere else. On the far left over here, we see this hexadecimal number, and that corresponds to the address where this code might reside when it's loaded into memory. Address space randomization can move it around to a different location, but that's where it might be. We also saw these addresses back when we used nm. These numbers over here that I didn't comment on before are the same numbers. We see that say hello, for example, is going to be at this address that ends in F00, and we see the same address in the disassembly as well. When we look at the disassembly, we see that the first thing this function does is use stack check guard, which is implementing the stack check. So to look at this more, let's simplify it a little bit by going back to compiling with fno stack protector and disassembling again. And now we see that only standard in and fgetS and the string and printf are being used by say hello. If we look at this in more detail, we see that say hello starts by pushing things onto the stack, pushes the register RBP. This is a stack frame pointer, and we don't really need a stack frame to think about what say hello and main are doing here. So let's also simplify by saying no stack pointer. I'm confusing that with no stack protector, no frame pointer. And it's also not no, it's omit frame pointer. Okay, let's disassemble that one more time. Now we see some relatively simple code here. So what is say hello doing? It's making some room on the stack by subtracting from RSP the stack pointer. That's the kind of thing we expected to see to make room for that local variable. Eventually it's doing a call queue here to call the fgetS function. It's eventually doing a call queue to call the printf, and then there's a return here at the end as well.